In September 2004, during a routine deep-sea cable installation in the Black Sea, a commercial survey vessel recorded something that was never listed in the final report. Not debris, not a shipwreck, not geological activity. It moved. Before we open this file, subscribe and enter the archive. Some discoveries are announced, others are adjusted, reclassified, and quietly filed away. In early 2004, a European telecommunications company began laying a high-capacity fiber-optic cable across the Black Sea basin, connecting coastal infrastructure between Eastern Europe and the Caucasus. The operation required detailed seabed mapping, sub-bottom profiling, and continuous ROV monitoring at depths exceeding 1,800 meters. The Black Sea is not an ordinary ocean basin. Below roughly 150 to 200 meters, its waters become anoxic, depleted of oxygen, and saturated with hydrogen sulfide. This creates one of the largest permanently stratified bodies of water on Earth. Marine life in the deeper layers is considered extremely limited. Large vertebrates are not expected to inhabit those depths. September 17th, at approximately 0136 local time, while surveying a trench corridor at 1,742 meters, side-scan sonar registered a dense, elongated return approximately 9 meters in length. At first, operators marked it as possible debris, perhaps a section of lost trawling equipment or a collapsed metallic structure, but the return shifted position. Sonar pings showed lateral displacement against the current. The mass altered orientation gradually, not tumbling, not drifting. The ROV camera was redirected. The video feed shows darkness, interrupted only by forward floodlights and suspended particulate matter. The seabed appeared flat, layered with fine sediment. At the edge of the beam, a contour emerged, curved, organic, tapering. The object rose slowly from the sediment. Operators later described the movement as deliberate but restrained. It did not thrash, it did not retreat abruptly. It rotated slightly, exposing a surface that appeared smooth but segmented by faint ridges running along its length. No visible scales, no metallic reflection. Biological. The head region, if it was a head, lacked the pronounced jawline of known large fish. Instead, the anterior portion appeared blunt, with a subtle ventral opening. Two darker indentations were visible higher on the body, possibly sensory organs or recessed eyes adapted to minimal light. The ROV operator zoomed. At that moment, a second form entered the edge of the frame. Smaller, approximately 6 meters long. It maintained distance behind the first. Then, both descended beyond the floodlight beam and disappeared into the darkness. The official log entry that night recorded unidentified seabed disturbance, likely geological. Internal notes from one engineer, later shared privately, described it differently. Two coordinated large organisms, movement consistent with vertebrate musculature. In the following 48 hours, 3 additional sonar anomalies were detected within a 5-kilometer radius. All ranged between 6 and 10 meters in length. All exhibited directional movement. None were captured clearly on video again. The cable route was adjusted slightly. No public mention was made. In October 2004, a separate maintenance vessel reported cable vibration irregularities along a segment laid weeks earlier. Engineers initially suspected current shear or minor tectonic activity. When an ROV was deployed to inspect the line at 1,680 meters, the footage showed the cable partially displaced, not severed, but shifted several meters from its trench alignment. The sediment around it appeared disturbed in a broad arc. No trawl marks, no anchors, no signs of external equipment contact, only displacement. Internal analysis suggested a mass greater than 2 metric tons would be required to move the cable in such a manner. No official biological investigation followed. Oceanographers have long debated the possibility of unknown megafauna in semi-enclosed basins. The Black Sea's isolation combined with its stratification makes it both hostile and protective. The absence of oxygen prevents most scavengers from consuming organic remains, which is why ancient shipwrecks are preserved intact at depth. If a large organism lived primarily near the boundary layer between oxygenated and anoxic water, roughly 150 to 300 meters, it could theoretically move vertically into deeper zones briefly before returning to more survivable strata. Biologically, the Black Sea presents a paradox. Its upper oxygenated layer supports familiar marine species. Beneath that lies a vast, hostile environment, largely uninhabitable to most known complex organisms. Yet hydrocarbon seeps, methane vents, and bacterial mats exist even in these deeper zones. Could a large organism adapt to such conditions? Theoretically, survival below the oxygenated layer would require extraordinary physiological adaptations: tolerance to low oxygen, specialized hemoglobin affinity, or even symbiotic bacterial systems capable of processing hydrogen sulfide. Some invertebrates on Earth demonstrate similar mechanisms. Certain deep-sea worms and mollusks thrive near toxic vents through internal symbiosis. But a 9-meter vertebrate? There are precedents for survival in chemically extreme conditions. The coelacanth survives in deep volcanic slopes. Giant squid inhabit near lightless depths. Greenland sharks endure frigid, oxygen-poor waters. However, the Black Sea's anoxic zone is uniquely stable and isolated. Its chemistry has remained relatively unchanged for thousands of years. If a lineage of deep-water vertebrates adapted early, possibly during glacial periods when sea levels and oxygenation patterns differed, it could have retreated downward as surface conditions shifted. The ridged segmentation observed on the video frame suggests reinforced musculature or internal structural support. The smooth exterior could indicate minimal external appendages, perhaps reduced fins to conserve energy in dense, stratified water. The presence of a second organism suggests population. Large vertebrates do not appear in pairs by coincidence at extreme depth without ecological stability. Some acoustic analysts reviewing 2004 data years later noted low-frequency signals recorded during the installation period. The signals were not rhythmic like whale songs. They were intermittent pulses between 16 and 20 hertz, below human hearing, and occurred during the same nights anomalies were detected. Coincidence cannot be ruled out, but the timing aligns. Modern Black Sea biodiversity surveys focus primarily on commercial fish species and environmental monitoring. Few systematic deep basin megafauna studies have been conducted below 1,000 meters due to chemical hazards and equipment corrosion risk. The 2004 company archived its raw sonar files. The edited public summary contains no mention of biological anomalies. When asked years later, one retired technician described the footage simply: "It was not a fish, and it was not wreckage." He declined further comment. If a deep-water vertebrate population exists within the Black Sea Basin, it would likely remain undetected under normal survey conditions. It would avoid surface zones. It would move slowly, conserving energy. It would exploit methane seeps, deep fish populations, and perhaps even carrion sinking from upper layers. Its coloration would be dark or pale gray, blending into low-light sediment fields. Its sensory organs would prioritize vibration and pressure detection over vision. And it would not need to surface. Cable networks now cross nearly every major sea on Earth. Thousands of kilometers of fiber-optic lines rest on the ocean floor. Installation projects regularly deploy sonar systems more powerful than those used in early marine exploration. If something large is there, it is occasionally seen. Briefly, as an anomaly, as interference, as a return on a screen that shifts position when it should not. The Black Sea has preserved ancient ships, Bronze Age settlements, and millennia of undisturbed sediment in its depths. Its chemistry conceals more than it reveals. In 2004, a commercial vessel encountered something that did not belong in its environmental models. No specimen was collected. No image was released publicly. No species was named. Only adjusted coordinates and archived data. Perhaps the anomaly was geological. Perhaps it was misinterpreted equipment echo. Or perhaps, in one of the most chemically hostile marine environments on Earth, a lineage adapted long ago to conditions we still barely understand. And somewhere along the silent stretch of fiber-optic cable lying nearly 2 kilometers below the surface, something large still moves slowly through the darkness, unseen, unclassified, and perfectly adapted to a sea we thought was empty.